Good morning and most welcome. Kalle Hashmi is my name. I work at IRENA with capacity building. I'll be talking about waste to energy. First of all, waste in general, and then waste to energy in particular. One of the basic things which I remember when I was in your age, and that was a long time ago, let me have it said. The main emphasis, when I went to college or to university, the emphasis in our lives was very much on growth. The word that was used was growth. And that is what the politicians spoke about, that is what the society in general spoke about, and that is what we as individuals strived. That we will come out with a nice degree and then we will have a wonderful house and we will have a beautiful wife and we will have a nice car and we will have God knows what. It all manifested in lots of material things materializing in our lives as soon as we walked out of the university. And that is what the government also spoke about. That is what all the government spoke about, was growth. I think when your generation is going to leave, you would not be talking too much about growth. You'll be using a word which is more in terms of development. Now, development has many more facets than growth. Growth is a sort of a linear curve which goes up, using more and more of materials, more and more of quantity of things. Whereas development has lots of abstract values also, apart from where consumption is one part, which you need for your survival, for your well-being, and to feel comfortable in general. And not necessarily with an overconsumption built into it. So our generation has been producing an enormous amount of waste, because that is what we were geared to produce waste. And we did it very well. I mean, we will start furnishing our homes by going to IKEA, and then you put it together if you find all the pieces, and then 3 years later, out it goes. And then you buy something else. And that is how whole of the society function, which is throwaway society. Every third year you will throw away most of your furniture and most of your things, and then you'll move on. You'll change your car every 4th year. And so it went on. So with the result, we have created enormous amount of landfills, as you can see, everywhere. And by the way, the first landfill was created roughly when? Any guess? When do you think the first landfill came into? You are all familiar with the landfill. You know what a landfill is. As being environmental people, I think you should know what a landfill is. The first landfill was 500 years before Christ, and it was in Athens. And the rule was that all waste would be deposited 1 kilometer from the center of the city. That was the first landfill that was created. Anyway, so that is how it was. Was there anything else that I thought I should take in the beginning? Yes, there are a few more things which I think we should remember. One is that you must remember is that anything and everything made by human beings is energy packed in one form or the other. Whatever you are looking at, whatever you can touch, whatever you can use, made by another human being is basically energy that you're looking. It may look like a pencil, it may look like a car, but it is basically you are riding an energy. It is energy packed. There's nothing in your world which is not energy packed. The other is, as you know, the law of thermodynamics. Energy is non-destructible. It just changes form. You can neither create energy nor destroy it. That is the law of thermodynamics. You can just change its form, which means practically you can pick up anything and declare it as energy, which means it doesn't come to an end after the burning process. That is what we think. The burning process is over. Now the energy part is goodbye, Charlie. No, the Charlie is still there and you can use it. The question is whether it is recoverable or not. And there are two ways to do it. One is if you manage to recover, then if you can reprocess that product, then you need very little energy to reprocess it. So you have an energy efficiency gain. So when you're looking at energy, do not always look at megawatts, also look at negawatts. That is also energy. It is, when I was teaching lighting, so we would always say, when you're looking at lighting, don't forget the darkness, because without darkness, lighting is uninteresting. They go hand in hand. So in the case of energy, you have two parts. One is what you call watts or megawatts, and the other is negawatts. So look at the possibility of utilizing both. That was the second part. Okay, what kind of waste do we produce? When it comes to waste approach, most of the countries actually are working with not handling waste after waste has been created, but they have started looking at not creating waste. That is the starting position, and that is the thinking position. And let's put it this way, as a consumer, you probably are not into that situation, which I see most people. You walk into a shopping mall, Lulu seems to be familiar, a shopping mall. You go in there and then you see lots and lots of frozen packaging, and it Majana it says, huh? You buy one and Majana one. That is the Arabic word for, I think, for free or something. So you buy one and you get one free. And then instead of making a small packaging, they try to make this big packaging, as a matter of fact. And then everybody comes with a 500 horsepower car, and there's no problem to load it in with this type of thing. Now you take a frozen food product, more packaging than you actually need for your consumption, because it's being offered to you at a cheaper price. You transport it and you put it into your freezer. You use enormous amount of energy to keep it frozen for 6 months. After that, you pick that bag up and throw it right into the trash. So actually it would be a lot cheaper and safer if they just bought it, went out and threw it in the trash. End of the story. So they will save all this energy that they have to put into their freezer to keep that thing frozen. So the society would gain a lot, as a matter of fact, if they did it, instead of having to throw it away 6 months later. And that is, but if they thought that, no, I really don't need it, I will not buy these 3 packages, I don't need 3 packages, I'm not going to consume 3 packages, I've never consumed 3 packages. Then this problem would not arise, and the shops would not sell it if the customers gave a signal by not buying bigger packaging. But it is so tempting. It seems to be, oh, I'm making a great deal of my life. So the first part is a mental perception of thinking from the beginning. So you will get into industry, you will get into works, you will get into jobs. So whatever you're doing, if you think from the beginning, oh, what consequences this would really have. Instead of thinking, oh, this seems to be cheap, little bit cheap to me, just, no, but look at the life cycle cost of it. The life cycle cost is you have bought food which you are not going to consume, you have to keep it frozen, you have to apply electricity to keep it frozen. Wonderful, if you took it out and you used it. But that's not precisely what you are going to do. You are just going to pick it up and throw it away. Thank you very much. The shop is happy because that is precisely what they want you to do. Because that is growth to them. Then the management can say, we have grown 6% this year too. So the owners are extremely happy. More money flows into it, so they can waste on useless things, even more of it. So that is the way it comes in, that we need a significant change in the way we think about waste. It's a mental process that we have to start, both among companies which manufacture and people who use it. If we look at the waste hierarchy, as a matter of fact, and you people are working with, or are hopefully going to work with, sustainable development. Is it understood? Is that what you are heading for? The first part in sustainable development is prevention. But if you absolutely need a thing, think about reduction from the beginning, and then figure out if it can be reused without having to dispose it, and if it can be recovered on site, or does it have to go somewhere else to be recovered? Can it be used by somebody else? Can it be recovered by somebody else? If nothing else, then off it goes to landfill. This is actually the whole sequence that you would be going through in life, both as professionals and as consumers. Because you are both roles. You must remember that you are also consumers. But you will be doing things for other people too. So if you are designing something from the, let's say you get into a situation and you have to design something. Think about the waste issue. Some of you are working with windmills. Is there anybody windmill guy here or no? But anyway, the interesting thing is that the windmills are becoming popular, for example, and renewable energy people say, oh, it's wonderful, it's very nice. At the same time, the people who are buying, they are looking for economies into it. They want them to be very efficient. They want them to deliver energy for practically nothing. That leaves only one option, which is to make bigger and bigger and bigger and bigger machines. Now, bigger machines are quite all right when they're working, but one day they will stop working. Now you have these huge monsters standing there with 300 of them. Now it is not a windmill, now it is a windmill waste that you have created. How do you handle it? How do you handle all these enormous towers that you have put up here in the middle of nowhere, where there is no road going, where there is nothing going? It was worthwhile taking it there because it was a new thing and it was an investment. Now it is not an investment anymore, now it is a total waste. And standing there, now you really don't want to have that logistical apparatus that you mobilized, these huge trucks to take it there. You don't want to do that, but you handle it. So if it is built in from the beginning to think about, oh, one day this is going to stop working. And somebody says, oh, you probably can take a windmill and take it from Europe to Africa. You can't do it. The trouble is that the material, the blade, has gone through so much structural fatigue. That is the reason they stop it. Not that the electronics or mechanical part has stopped working. Everything is working. It is just that the blade has reached like an aircraft, which will stop flying after some time. Not that it can't fly or the engines are not working. It is just that the structural fatigue in the material has reached such a level that it will just fall apart. And you don't want something which is spinning around all of a sudden just break off and go 200 meters from there, flying nowhere. You don't want to do that. You just don't want an aircraft to implode in the middle of the air because it has reached such a structural fatigue in the material. So it is the structural fatigue which leads to that you have to stop it. Now you have to recover it. Wonderful. Now this is not something which you can put in your pocket and take it from there. So it would be quite interesting that somebody sat down and figured out that, oh, it has to be recovered, and how could we make it in a way that the recovery becomes an issue. And in the same way, what do you do with all old PV panels? What will you do with them? So, and there'll be all of a sudden lots of them available. They do not have too much residual value. So in a way, so prevention actually to make it easier is to design from the beginning. I'm going to start with the construction industry. The reason is that the construction industry in our lives is an industry which produces maximum waste out of all the industries that we know. Normally, a person in UAE produces about 2.5 kilograms of waste, which is the average 2.5 kilogram a day roughly they are producing. So, but on the other hand, this industry can produce something like 10 kilograms of waste per person when they start constructing something or when they start demolition of something. So this is a big waste producers. Whatever you are doing, actually, if you talk to the designing people, because it is how things are designed that it makes it possible to recover easily or in an extremely difficult way. It makes it possible to dismantle them in an easy or in a very, very expensive way. And they could require additional waste if putting them into place requires lots of other things. So in a way, it is always at the design stage where you can save most money by designing things from the beginning in an intelligent way, so that the recovery becomes easier, recycling becomes easier, disassembly becomes easier, and they do not require too much activity for assembly, which is waste creating in itself. And this is precisely what the construction people don't do. Try to install an air conditioning system in a building. I mean, it's an enormous amount of piping, and there are lots of other things which you really have to bring from other people, and they bring an enormous amount of packaging with them in order to handle that. So they create their own waste streams afterwards, depending on how the initial system which is to be installed has been designed. This actually gives you an idea how the whole system is engaged in it, and most of the parts of this system create waste. That is the other part. When you go in and you are going to work in real life, think in a holistic system way rather than just looking at a component level. Suppose, for the sake of argument, if the cars disappeared, tomorrow there was no car. It's not just that the cars would disappear. There's enormous other activities which will disappear. All the gas stations would not be needed anymore. All the delivery trucks which are delivering all this gasoline here and there would disappear all of a sudden. Emergency services at the hospitals would disappear, who have to take care of people who are hit in accidents and so on and so forth. All the repair facilities which are looking for damaged cars and servicing cars would disappear, as a matter of fact. So if you keep on adding up, you will see that there's an enormous amount of activities which will disappear. But if you turn it around, then you say, oh, whatever I'm doing is interlinked to an enormous number of other activities and has consequences for those activities. In the same way, a designer starts the process which affects everybody in every direction. It is his thinking which creates an additional amount of activities, and all extra activities require energy, if nothing else. So energy is wasted, if nothing else is wasted. So wherever you go, whenever you are working with something, you are looking at it, think about, has it been designed in an efficient way? Because otherwise it will add to follow-up activities. So there is a need where The industry has missed in many, many cases, and you will find out when you start working out in the industry, is that the industry is organized in a linear way, where you have research and development is somewhere hidden. It's very secret what they are doing. Nobody should know it, because then it will go to the competitors, so they don't talk to anybody. They are the hidden people, and nobody is allowed to go there. There's enormous amount of security apparatus. So you can't enter those areas. All the communication with the market is through the marketing people. And then you have the procurement people who have another contact. They are not interlinked with each other. The research and development people are supposed to bring out surprise for everybody, a big surprise. Life would be a lot easier if they were interlinked with the marketing people, and the market people were interlinked with the real world, which they are to some extent, and they ask real questions, and they transfer those real questions to research and development people. That would make designing quite rational. That think about it, this is how people install it, this is how they handle it, this is how they do it. Can you design a product from that perspective, as a matter of fact? The other is you have the procurement people. Now the company is extremely geared to looking at its own operation. But 80% of their troubles start by buying something which is not properly made that they integrate into their system. That is where the trouble starts. And now the industry is moving to a very rapid extent in a just-in-time. Just-in-time basically means that previously you had an inventory. Things would come, they would be put into a store, you would go into the store and there will be lots of things lying there, and you will pick up a screw or whatever you needed. That is how the industry worked. Now the industry thinks it's too much cost to have this kind of inventory lying around. Now they have an inventory for one day's work. Whatever they're going to use during the day, that is the upper level of inventory, which means your inventory basically is on the truck outside your company, on your supplier's truck. You still have an inventory, but now it is in his truck, and he's waiting outside your gate to deliver your inventory. And he delivers it on a daily basis. Okay, you have your routines and so on and so forth to check things. But if the things are going to go into the system in the next 4 minutes, then you have to be Einstein to figure out that everything really meets the specification and requirements. So bang comes this thing right into the system, and out goes something which you can't use. That is the trouble that you are getting into. So these things have to be actually, that is where the waste starts creating. So once again, research and development people are not linked with the market and real world conditions the way they need to be linked. With the result, they do their designing based on getting all the product. Oh, let me tell you how the research and development process in industry goes. Oh, it's very simple. You are going to make an iPhone. You take in all the mobile phones of your competitors, tear them apart, and see how they are put together. That is research and development. Whatever is interesting that you have done, you see to it if it can be copied without a patents breach or not. So it goes to the patents people to see what is it that we can copy out of it without getting into a patents breach. So you have lawyers actually who are supporting the research and development people. So these patent lawyers tell them, this you can steal. If you did this, we think we can defend it. Otherwise, we can't defend it. So then you come back and then you do a little bit like this. In the same way, you pick up the cars of your competitors, you tear them apart, you just slash them in the middle and see exactly what they have done with what. And then including lighting or whatever it is in it. And then out of it you figure out, and then you change a little bit here and there, and that is called your research and development. So basically your effort is not interacting with the consumer to a very large extent. It is pursuing your competitors to a very large extent. So the onus of effort is basically in the wrong direction. So if you end up in companies, the first thing I would request you to do is to see to it that your marketing departments are linked with your research and development departments in a way that the products are designed from the beginning, that they are recoverable in a very easy way. Whatever can be recovered can be recovered. And that is extremely important because all governments are going to impose a producer responsibility in the future, which means whatever you sell to the consumer at the end of the day becomes your responsibility as a supplier to recover it and to do something. So to make your own life easier, you should design it in a way that you can recover whatever can be recovered, reuse whatever can be reused, because you would always have components in your system which have 50 years life and components which have 5 years life. And to a customer, it doesn't matter how the inside looks like. To him, what really matters is how the outside looks. If it is even a used component, he would never know it as long as you can provide guarantees. So that is one part of thinking, that the research and development should be closer to the customer rather than hidden in a basement or very secretive. It should not be that secretive, as a matter of fact. And the other is to have a systems approach, to think how the whole system would be affected by your action, how you are interlinked. That is actually, when you use the word sustainable, why the word sustainable has come in is that all of a sudden the world has realized that as far as environmental aspects are concerned, there are no national borders. You cannot say this pollution is only limited to UAE. There's nothing which is limited to any geographical area. It has become a global problem, as a matter of fact. Okay, now you've got a holistic approach, that we are all interlinked. But don't make it at that very high level. Even in your business activities, think about how your actions interact with others' actions and how you are interlinked in whole of the system. And if you have any influence on the system, try to make the system rational. And no. Okay, now when it comes to the waste process, it is very simple. It doesn't require an Einstein to understand it. Basically, you have to do is to identify where the problems are, investigate what you can do about it, and then do it. And this can actually be applied to buildings, it can be applied to systems, it can be applied to installations, and so on and so forth. When you are identifying, then you are identifying for the opportunities to reduce material. That is one of the first things. Less material you have, less processing you have, less problems you have, less energy you require to process, and less waste you create. Very simple. So try to reduce material. Less material, less processing, less energy, less waste, and less. Everything becomes less if it is. So the first is to look at how the waste is being created and can it be eliminated. And then have the opportunities that you can utilize, and then you can't use all of them. That is not possible for a company to do. It will be very, very expensive. So you really have to figure out what is rational, which makes economic sense, and which can be done with the apparatuses that you have. So that is the first part. And then to investigate the design opportunities, to further ascertain the viability. This may include such as compliance, but that is what you have to do. That you must remember, that when you are trying to apply things and trying to reduce waste, you must comply with the standards and safety issues. So you are not compromising any mandatory requirements. So that is critical, that the mandatory requirements are met, and after that you are able to remove whatever needs to be removed. Okay. Then of course you implement. The other thing which is quite interesting is that when you are implementing, it might be that you have reached a conclusion and you have done, but in reality it has to be implemented by other people. So see to it that those people are informed who have to do it, so that it doesn't become an issue with you only. This I have spoken about, that what is extremely important is to think in terms of system and not just in terms of products. And one of the oldest system approach has been the military people. You see, killing other people is not the easiest thing on this earth. It requires mobilizing lots and lots of services. And in old days, military has been operating for at least 5,000 years now as an organization. And the trouble is, when you move 500,000 men, it becomes a big issue. I mean, very simple things are very complicated. To supply water to 500,000 soldiers on a daily basis is not the easiest thing on this earth. It looks quite easy, but it is not. Forget about everything else, just giving them water, which is a couple of liters of water that they need a day, at least 2 liters of water on the average, if it is going to be normal, or at least 1 liter of water. That is about 500,000 liters of water on a daily basis that you really have to mobilize. Then they are going to eat something. They have to live somewhere. It might be cold and you have to heat them up, or it might be whatever. And after that, they may hurt themselves, which of course war leads to some people getting hurt. It's a bad business. So in that sense, somebody has to repair them. Somebody has to pick them up from the battlefield. Unless they know somebody is going to pick them up, they won't go to the battle. So in that sense, you have to put one infrastructure after the other and the third and so on and so forth. It wouldn't work if the military leadership didn't have a systems analysis thinking. I mean, they have to think all these things in a cohesive way, how things are going to move. Otherwise, you would end up like Napoleon. You ended up in Russia. You took 500,000 men, ran out of food because it was winter and there was nothing to eat. So the Grand Army perished. No matter how good a commander was on top of that. End of the story. And there was no way he could, and 500,000 soldiers could survive in Russian winter. So have a system analysis in your mind when you are dealing with things. Now we get into when it comes to waste management, then there are basic functional elements which we have gone through. One is generation of waste. Can we do something about it that we do not generate that much waste as we are generating? That is one part. The second is, if we really have to generate waste, can we reduce it? Is it possible to reduce it? And after that, how do we collect the waste that we have generated? And can we recycle after we have collected it, or recover something? And how do we dispose it off in an environmentally friendly and a nice way, as little as possible? I mean, the idea is that the disposal should be absolutely minimum. Recycling, if possible, should be as much as possible, and generation should be as little as possible. This is minimalistic, this is minimalistic, this is maximizing, as a matter of fact. And then collection is also maximum. And they have to think through, exactly as a military organization has to think through the whole process. Once again, when it comes to designing out waste, it is basically source reduction, which is much more important. Reducing it at the source is much easier than release. Release is when the product has been released or a system has been installed. That is where reduction becomes much more expensive. It becomes much more difficult to do. It's cheapest, it is easiest if you think through it from the beginning, and right at the source you can do something about reduction. And we believe that the best management approach to waste is to manage the process so that there is no waste to manage. That is, of course, an ideal situation which is difficult to attain, but it doesn't hurt in saying that we are moving in that direction. That is our hope and prayer that one should have in life, and a vision. Since that is not totally possible in this world, then the question arises, can the amount of waste being produced be minimized, if not eliminated? That question can always be asked and is answerable. And once again, I'm concentrating on design because that is absolutely the critical part. So I want you, when you go from here, if you remember anything, so that would be the part that you should remember. Everything else I can live if you don't remember. But whatever you are doing, it design it from the beginning in a way that it is possible for reuse and recovery, and it is off-site construction if that is possible, design for materials optimization, design for waste efficient procurement, and design for deconstruction and flexibility. Because if you design it in a way that the procurement also becomes material efficient, that is, I mean, if you are minimalistic in your in whole of it, that you are not too expensive, using too much material, then the procurement also becomes very, very simple and less material intensive. And that is what you are trying to do. That in whole of this process, you are trying to reduce the waste. Now we get into eco-design, as they use the expression now, which is becoming very, very popular. And eco-design basically is that a product innovation which leads to less material waste. And the other is to look at the existing products and ask yourself the question, can they be redesigned that they use less material and create less waste? And the other is, when we use the expression energy efficiency of appliances and so on and so forth, waste is not only limited to the equipment itself, it is also associated with how you are going to run it, how much energy you are going to run it. And you really get into situations, for example, they have energy labeling for, say for the sake of argument, for washing machines, where they would say, oh, this is a very energy efficient washing machine. But on the other hand, for a country like UAE, you start using it and then you realize it has the highest water consumption in whole of the world, but it uses very little energy, but it uses an enormous amount of water. But you don't have a declaration for water, so they don't tell you that. So there could be something else to attach to it. So once again, look at the whole thing when you're looking at it. There's the total resource which is required to do the process, and not just one part of the resource. That is also important. And when you are doing product redesign or product innovation, then look at all the inputs which will be going in to maintain it, to run it, and so on and so forth, and not just one component where you have a possibility to market it. The other is, when you are redesigning a product, bear in mind, can you change the function in a way that the waste is not. I'll give you a simple example. Let's say you are producing an electronics equipment. Normally in electronics, you have components which are linked with cables. That's all. When you're designing, you don't care what color is on the cables, for example. It really doesn't matter. It could be any color on the cables. It's a very simple component, standard component. Now if you have two cables, one is brown and one is red, lying besides each other, and you are an assembly operator in my age, I'm 63 years old. In Sweden you'd still be working, you retire at 65. So you'll have old buggers working, or an old woman sitting there putting together these two things, welding them or soldering them or whatever. The likelihood of her interchanging the cables increases. because she can't differentiate very well between a strong brown and a red. At some stage, she will miss. That is waste. Now that product won't function. It will go through, everybody will put, and then they'll switch it on, it won't. End of the story. It has to go back through the whole system or just thrown away. Or it might just go through the system because they will check every 4th, 5th, 6th. They might not check it up. Now it has gone to the customer. Wonderful. It has gone all the way from Shanghai to God knows northern Scotland, and the customer plugs it in. Now they have to bring it all the way back to Shanghai because the store will send it back. The customer, a very unhappy customer, will come to the store, and the store will pick it up and send it back. That is waste. So that has been created because somebody didn't think that these two cables were that important in his designing operation. So, I mean, the very simple things lead to to this kind of problems. So, in that sense, I think this has to be thought about when you are doing this kind of thing. Now you people are working some of you, for example, are working with solar panels. Is there anybody in solar panels? No. Are you all system engineers? No. Well, anyway, you people are close to PV panels and those type of things. 85% of the problem with them are not because the equipment technically is not sound. 85% of the problems are because it's wrongly connected. And it only becomes wrongly connected because you do not make it in the way from the very beginning that it would not be possible to wrongly connect it. If somebody designed it that way, then there is no way. If you make a plug which will only fit one way, there would not be a two-way that you can do anything with it. And it doesn't require an Einstein to design from the beginning a plug that no matter who comes in, he would only be able to assemble it in just one way. There is no two ways.
When you mentioned the connections with PV panels are not exactly right, could you be more specific? What sort of connections are not exact?
It is like this, that you have two parts into PV panel system. You buy the panels, now they have to be converted into a system. Now the panel has come, now you buy all other components to link it to the system. It goes to an inverter and it goes to lots of other things. Now you are moving through cables and they have connectors and they have so many. That is where that is where the systems fail. And the trouble arises because the panel manufacturer thinks, oh, I have made the panel, thank you very much, goodbye. But if we were to take one step further and saw to it that there was a cable coming out of it which only fitted a certain plug of it, life would be very simple and life would be easier. So in this way, actually, this is becoming important to think about. So the question is, one is, can the product be redesigned in a way that it produces less weight? Can we change the function in a way of the product that we are using that it produces less waste? That is also of interest. Can the function be affected in a way that it is that it would have a bearing? One way is actually, there are two ways. Let's say when people get older, they have difficulty in seeing. That automatically leads to higher levels of light they require. If you were to look at I was talking to my colleagues, if you were to look at a 60 years old person versus a 20 years old person, which most of you are, the amount of light a 60 years person needs to perform the same task at the same speed as a 20 years old is 6 times. That's lots of energy you need to perform the same task at the same speed. The only thing which has come in between now is age. Nothing else has changed. The question is, can you change the task itself in a way that you don't have to provide 6 times the lighting to do the task? Or shall you assume that it can't be? Of course it can be. So, which is of course by changing the size of the task, for example, which is very much possible to do on screens and computers and so on and so forth. So there are ways. So in a way, that part is mostly missed. Why are we making this thing? That question is normally not asked. In the beginning, I mean when they are introducing it to the market, they ask it. But once they are into the market, then it is established. But I think they should revisit once and again and ask, why are we making this thing? To do what? Can we see to it that the task itself is changed slightly so that we can make it in a more energy efficient and environmentally friendly way? So what I'm trying to say is that there's an interaction between the task for which the product is made and the product itself. Whereas we concentrate on the product or the service and not on the task. So there has to be somewhere a linkage between these two parts too. And that is important for you. If you are working with something, try to figure out what is happening with all the things that you are making. Why people buy them and for what purpose? And can we do something for the purpose that they use it for so that they can be done in a slightly different way? I can tell you, I don't know, there are many old people in Europe, and most of the old people, I'll tell you the functional problem, and then I will tell you how it was. It's interesting from real life. You see, when you are born, you need a diaper. And as you get older, you also need a diaper. That is, you start with a diaper and you end with a diaper. That is c'est la vie, which means that's life. You can't do much about it. So diaper to diaper. So there are lots of old people in Europe, and they're getting older and older. And many of them are in daycare, they are in nursing homes, as they call them. And labor is very expensive in Europe. So with the result, they try to rationalize labor. So one of the things that these people do is that when old people in the evenings, they at a certain given time, they put a new diaper on them automatically. Whether they needed a diaper or not, they just, since they had to finish their task at a certain given time, so automatically they would put on a new diaper. And that irritated lots of patients to a large extent. They thought the diaper was okay. It also created enormous amount of waste because you were just throwing away the old diaper, which was reasonably okay as a rational process. So it doesn't look much, but that was a fairly large amount of waste because Europe, 20% of European population is over 65 years of age. You have to remember that. So it turns out into an enormous number of diapers. Now that's the problem. I mean, you have high labor costs and you need to change the diaper, and you are creating enormous waste. Are you with me on the equation? Lykke was very happy. That was one of the European companies which was making all these diapers. They could sell as many diapers as they wanted to have. But then somebody at Mölnlycke asked this question, that we are just generating this waste, can't we do something about it which will benefit our customers and the cause and so on and so forth? So they went to a small company which had come from military research in Sweden. Imego is the name of the company. And they were previously making what military people call booby traps. Booby traps are type of things that just explode. They look like grass, or they would look like a leaf, or they would look like something. And you just walk around it and bang. It just gets under your feet, and then you have some of it gone. So they're called booby traps. So you produce lots of them to hurt other army soldiers. So they were working with those nasty things, these people. So they're basically sensors that they were producing. So they went to them and said, can you possibly produce a sensor which will give a signal to the nursing people that that patient needs a new diaper, but that patient and that patient and that patient's diaper is okay, so that you don't have to change those diapers, just change those which need to be changed. So they produced an electronic sensor at 1/10 of a fill. The cost of it was 1/10 of a fill. So they could integrate it into every diaper. And it was integrated into every diaper, and it is being used all over in every diaper. With the result, you have saved enormous amount of waste. At the same time, old people are extremely happy because these nurses don't come and bother them too much, and nurses are quite happy because they have to change very few diapers, which they don't have to. So the world has become a lot better place, and you have saved lots. Okay, this was a linkage with not making just diapers efficiently. It was a linkage, where does this diaper end? The function that this is performing. Can we do something with the function so that the waste is reduced? Are you with me? Hopefully you won't need that diaper. That is my prayer for you. Much of the waste that comes into a company has to do what they are procured. What they have procured, and they are processing it. If they procure something wrong and start processing it, then the whole of the process leads to waste. And we did actual measurement among 70 companies. They were all quality assured, these companies. The average was 15%. 15% of their turnover was that they couldn't sell. They had produced waste, not saleable products. Now it was waste of labor, it was waste of energy, and it was waste of material. A product that you cannot sell is waste of material, waste of energy, waste of labor. So these are three wastes which have come up. Now that product is lying in a dustbin. End of the story after all the labor you have put into it. And that accounted for 15% of the sale of these companies was pure waste. It was just that they were quite used to it. Oh, this much waste normally is produced. It looked very normal to them. But that was a huge amount, and they didn't make that much profit, as much waste they were making. They had more waste than profit. So one of the first things that was basically done with those companies was to reduce the waste levels to about 2%. So it took us about 3 years to do it. But then it finally started working. So that is a big part. But I don't think so you'll get into it. Anyway, what I was going to do, because we are coming to packaging, is actually a very, very important part. And there is somebody were talking to me about running a project, and you were telling me about the retail trade. One of the things that we were looking at actually was packaging. What to do about packaging, and to reduce the amount of packaging, and to simplify packaging. And one of the projects that was run in France for a long time, very successfully, was labeling packaging from the perspective of if it was material efficient, if it was biodegradable, environmentally friendly, and so on and so forth. So the packaging carried this information, a very little label which the government would put into it, and not an independent organization informing the customer packaging. The other was the requirement from the shop itself that they must get material with packaging which was with very little waste in it. So that has been done. What I was actually going to talk now is, I'm not going to continue with this thing, I'm going to talk about something else which we are looking at from IRENA in this region. One of the things which strikes one when one comes to UAE and GCC region is the climate, which is hot, which leads to an enormous amount of air conditioning requirements. The energy production in UAE is totally about 90 terawatt hours, and they believe about 40 to 45 terawatt hours annually is used for cooling purposes in the buildings. It is called built environment. We are talking about not industrial cooling like dairies and so on and so forth. We are talking about cooling in this kind of buildings and commercial premises and homes. That is where an enormous amount of. At the same time, they have a very large number of energy intensive industries. They have petrochemical industry, which is very large. They have aluminum plants, and they have iron and steel industry. They have cement plants, which are all energy intensive. Now, the fundamental principle of combustion is that heat is unavoidable. You can't have combustion without producing heat. It's not possible, physically, theoretically. No matter how hard you try, you end up producing heat. And if you're running a power plant in this part of the world, which are big, 1600 megawatt units, they are 35% of the energy they put into it goes to producing electricity. Now 35% you have got of whatever you have put into it, your total energy value, 35% has come out as electricity on the other side. 65% goes through your stack. Thank you very much. Nice being a part of this company. No use. Goodbye, Charlie. So 65% of the energy goes as heat out of your stack. No use, not interested, don't know what to do with it. Some of it they have started using for desalination plants. When they get into distillation activities, then they need heat. But otherwise it just goes out. In the same way, cement industry has lots of heat that they produce. Clinker they make at around 1400 degrees, and then they have to cool it and grind it, and that is cement. You start with limestone, you heat it up to 1200 degrees, it turns gray and becomes stony, and they call it clinker, and you grind it and you call it cement. And you heat it up, limestone, and then you cool it. In your cooling process, there's an enormous amount of heat that just disappears somewhere. In the same way, refinery industry produces enormous amount of heat in its processes, but too little temperature for them to use anywhere else out of the stack, and it goes. So the heat sources are enormous in this region and not being used for anything, as a matter of fact. So one of the projects that we are looking at very seriously to introduce in this region is to use waste heat to produce cooling through district heating networks, which means that you will recover heat from power plants, recover heat from cement, from steel plant and petrochemical industry, and feed it into a network of pipes. I mean, there will be pipe coming from each one of them carrying hot water, around 95 degrees to 100 degrees hot water. That will go close to the building, and you will be using an absorption chiller. The absorption chiller works on heat and not on electricity. So with the result, you will be able to convert heat directly into cooling, delivered at 5 degrees temperature on the other side, 6 degrees to the building. And that is what you require, 6.5 degrees. So in this way, the hope is that instead of getting into energy efficiency, which probably they are working very much with, making the air conditioners more efficient, a little bit more efficient, and those type of things, the idea is to disconnect it completely, deliver just hot water to absorption units and to deliver it, and to get them out of this air conditioning based on electricity. The other is hot water in this region is also produced based on electricity, and all individual homes have some sort of heater installed individually. So in this case, you have hot water available now. Just pump it directly into the system and not having to produce it yourself. So in that sense, the other is we would also be working that the hot water is directly connected to the dishwashers and directly connected to the washing machines. Now the washing machine is connected to the cold water today. If you go home and have a look at it, you will realize that your washing machine is connected to the cold water, which means you use electrical energy to heat up the water first to the temperature where you want to, and then you do the washing. In this case, bang, it will come in right with a thermostat that will adjust it to whatever temperature you want, 40, 60, 90, and it will be into the machine directly. One is it will start very quickly, so your machine won't require 4 hours. This baby will move very quickly because heating up the water takes some time, and that you would save immediately. So that is the other big deal. The other thing is that once that hot water has been used, then the temperature is slightly lowered on it. It's not that it has started at 60 degrees inside your tap and then you have reduced it to 2 degrees. It is not, it is still, we are talking of something like 20, 25, 26 degrees water that you are getting on the other side. And the idea is that all that water should be taken through heat pumps. Now heat pumps have a coefficient of performance about 5 times. So with the result, we will be able to reheat it through a heat pump again. So see to it how much we can recover out of it. And that becomes incredibly effective in this part of the world. One, the system efficacy is high on heat pumps. Two, the electricity price is very low to run the heat pump. I mean, it is 15 fills. It costs nothing, as a matter of fact. So you have a double bingo. So you can really do both the things. So in that way, you'll be able to recover energy. The third step, which is more imaginative, is to move the region completely towards equipment, appliances, which are run on heat, which is absolutely possible. A refrigerator does not need to be run on electricity all the time. It can be run on heat, once again through an absorption chiller. It's just that you will have a problem during nights, but normally people don't open the doors of their refrigerators and freezers too much in the middle of the night. This is only during a few hours early in the morning and so on and so forth that they jump into it a few times, even if you have children. So our feeling is that if it is well insulated and properly made, it might pull off a 10-hour shift and so on and so forth. The other is not to base it on a solar system, but to keep on running it on hot water, which will be available 24 hours, because the industry continues to run 24 hours. So there would not be a problem. Still, we will give it a shot to shift to hot water-based appliances rather than running it on electricity. And if we can pull off this racket, our feeling is that we will be able to reduce electricity consumption in the region by 50% in one go. That probably is the biggest energy efficiency you can do instead of dealing with individual appliances to a very large extent. I mean, in this way, why I'm taking it in front of you is that when you're looking at things, try not to just look at them as they look. See to it if this problem can be tackled in a different way. Don't concentrate on equipment, concentrate on the problem. The problem in this case is they don't care how cooling is performed. I mean, do you really care how this building is cooled? No, you just need cooling. It may come from anything as far as you are concerned, as long as it's comfortable. You don't want it to be too hot, 27 degrees or 28 degrees, that's all. Or 6 degrees, that's too cold. So your basic concern is provide us a service, that's all. So if you look at it and ask yourself the question, can this service be provided in an effective and energy efficient way and in a cost effective way than what we are doing today? Using less resources, creating less waste, using less materials. Now from there moving on, what comes up is that you can pump into it the heat from the incineration facilities. They are getting into municipal solid waste. They produce about 20 million tons of municipal solid waste. They have recycling facilities, they have recovery facilities. And the basic principle is you can recover about half. You have 3 components. One is Organic waste, food. That you send to composting and make biogas out of it, which is a normal natural process. The other is the parts that you have recovered, you try to recycle it. It can be bottles, it can be cans, and those packaging and those type of things. So that you use to remake whatever you can remake out of it in an easy way. The third is what you can't do anything with, which you can't recycle or recover. Now you burn it. That is what incineration is. That's about 48%. So 48% of 20 million is about 9.6 million. And 9.6 million can give pretty close to it is 9.6 million tons, and it can give pretty close to about 7 terawatt or 8 terawatt hours of cooling. And that is a lot. So with the result, you will pump in. Now the question arises, why are we not transporting cooling? Why don't we just put up a huge facility which is producing cooling and transport cold water instead of transporting heat and converting it into cooling at a nearer range? The answer is that if you start distributing cold water, you need enormous amount of cold water because you will be directly using it. You are not putting water into it to do something with it. You use it as it is. It will come at 6 degrees and you use it. So you have to provide it for all the buildings, which leads to you need at least a 3-meter diameter pipe. That's a big baby to put in the ground, and that's expensive. And you insulate it because this is a very hot climate. So now you have a 3-meter diameter pipe and you need about a half a meter insulation on it. So you're pretty close to 4 meter diameter pipe you are talking about. Try to have curves on it and everything and take it from you'll be digging huge holes and people will be totally lost into that. Whereas if you're transporting only hot water, you'll be adding one, cold water into it to get into your taps at the place. So you don't have to transport that you are already transporting there, which can be added to it. The other is it will convert into cooling on the other side in sufficient quantities that you need. So if it is only hot water at 100 degrees temperature, you need a 60 centimeter pipe. So now your piping becomes easier. That is the reason. The other is collection becomes easier. If you are going to collect from industry, they don't have cold water. You go to a power plant, he doesn't have any cold water. He can't supply you cold water. He'll just can say, I have excess heat, pump it into the pipe, thank you very much, and off it goes. And in the same way from a cement plant or whatever it is. So you can collect heat from all these points and bring it together and distribute it. And the thinking is that it should be jointly owned by basically the power plants. We believe and hope that the power plants are producing enough waste heat that it might be enough to get this thing going to a large extent. So they could jointly own the system in which they will feed, and whatever profit they will make, they will share it. So that is how the thinking is, that the system should be collectively owned by the suppliers and the distribution company, because these suppliers would not put piping. Somebody has to put this big piping in the ground. So that would be done by the distribution company, but they together with the distribution company would own the whole system and whatever profit they make. And the cost calculation is as follows, that electricity is only about 15 fills, but cooling at the end of the day, taking into account your investments in equipment, maintenance, and so on and so forth, ends up pretty close to 44 fills. So producing 1 kilowatt hours of cooling is about 44 fills, whereas energy itself for doing it is about 15 fills. But that is just one part of it. So what they have to do is to supply it less than 40 fills. So they are competitive, as a matter of fact. So that seems feasible because they have no price. Heat doesn't cost them anything as yet. So whatever they can get out of it is profit. So it is not something that they really have to commercially price it, because there is no commercial price for it. It's waste. It's of no use to them. So it should be extremely low. The feeling is that it could be probably sold for less than half a fill per kilowatt hour heat, something around that. So in that sense, it becomes very, very competitive with electricity, which is fossil energy based, and would be able to provide cooling. Now, from your perspective, from sustainable perspective, is that when you're getting into sustainable energy, you have to remember that you will be competing with established systems in place. It is not that you come to UAE and say, we want to introduce renewable energy, that there is no energy. There is as much energy as you want. It's already being covered. So you have a system in place. What you are doing is that you are complementing that system one way or the other. So in that sense, you have to be incredibly cost competitive with the existing system which is in place, which is always not very easy. But in this case, the thinking is that if you de-link the biggest component of energy consumption in built environment, which is air conditioning, then the energy requirement that you have after that is basically for lighting. Because now you have solved the air conditioning problem, now you need electrical energy for lighting. Lighting you can't do with anything else. And running your TV and all those type of things, that is what you would need the electric power for. That load, we think, is sufficient to start looking into alternative at a competitive rate. Because now your load is substantially reduced. But if you have too big a load, then your roof is not enough to take care of alternatives. You would need huge amount of roof surface, which you don't have. So with a limited roof surface, you can only perform some functions, which you can't do otherwise. So that is the thinking, that it may open up a possibility to get in, not 100%, but maybe pretty close. So this is what we have been thinking, and this is what I'm working just now to see if we can take it to a logical conclusion. And our hope and prayer is that the utilities, power companies won't feel threatened in any way. They shouldn't, because they'll still be selling whatever they're selling. The difference is if the household stopped using electricity for air conditioning, the power becomes available to create new energy intensive industry. That is much better use of oil money than just to burn it in air conditioning units, because industry at least creates value added, it creates jobs, it creates many other opportunities which an air conditioning in a house does not in the same way. So the opportunity cost you have to take into account. So we believe it will benefit the society at large if they were to. So in that sense, when you go into real life, I think look at issues in an issue way and think if it can be solved in a different, or if there's another opportunity which can be exploited to solve this, rather than the way we have been doing it for 5-10 years. That is the whole point of education, to give you analytical, critical capabilities, to look at a world in a very different way than what you did. Otherwise, the education has failed. If it doesn't make you a critical, analytical person, but it will also make you a troublesome person, because if you come up with innovative ideas in an established world, you rock the boat. But somebody has to. Otherwise, we would all be going around with skins the way we were going 1500 years ago. The world would have looked the same unless somebody thought slightly differently, for the better or worse. A newborn child in 1 year's time can produce 1 ton waste. So there is last question that I have, I asked my colleagues and I will ask you too. How many banana peels it takes to drive a standard car 1 kilometer by composting them into biogas? How many do you think? Banana peels, not whole banana. You can eat the inside, whatever is left, this yellow thing, not the white thing. How many of them, if you were to compost them into biogas to drive a standard car, not these huge Toyota Prado type things, but just a decent taxi, for example, taxi type cars, 1 kilometer, how many? Give me a guess.
61.
Huh?
Kilogram. I think maybe 5 tons.
Come on. 10. 1, 0. Only 10. Only 10 banana peels. Only 10 banana peels are enough to run a car for 1 kilometer on biogas. And that is a very unexploited opportunity even in this world. 10 banana peels are available everywhere.
What about after course?
I haven't done it, but that's an interest. Why don't you guys do a study on it and run a car and generate some knowledge around it? That would be interesting for IRENA.
Does anyone have any questions?
Sure.
You mentioned about the recycling facilities over here and how so the plastic and the aluminum is separated out. They have the organic fraction separated out. So do you have any information on if any of the facilities are producing value added chemicals like like fertilizers or other chemicals from their organic fraction or from the inorganic fraction?
One unit actually is doing is producing compost, if you will call it a biofertilizer. One company is doing it.
In the entire
In the entire region.
I
But
mean,
none of them is actually into incineration. They are not producing any energy, but they are producing composting. So they have come that far. You must remember they've recently started. But if you were to compare with the city of Stockholm has 0 landfill
yes.
because they have burned about 59% of their waste into, and now they have run out of waste because they have become very efficient in minimizing waste. So Sweden has started importing waste to burn in its facilities. So that is an interesting trade. I mean, you import trash from other countries. What do? We burn it here. And the other countries pay for you, will pay you for it. So it has become a very interesting business for them to burn the trash of other countries, Norwegians especially. But there's only one facility. Nobody is producing electricity or gas at this stage. Taka is planning to put up a facility to do that. I don't know when that would be ready. But at this stage, they are into sludge extraction. They're producing some biogas. So that is very, very limited. But sorting has got going, so they are sorting. And one more question. I mean, if you recover an aluminum can and you have a standard, say, 40-inch television, that big one, how many hours can you run it if you didn't have to remake that aluminum can? 3 hours. So it is.
I have a question regarding one of the things you talked about is when you design so your product can be reused easily. I'm interested from a building point of view where your building lifetime is 50 plus years.
Depends where you make.
On the American standard, you design for 50 years as a general.
Yeah, but in Europe, I think the average building would last about 600 years.
Yeah, so often it will last. Well, today they're not as well built anymore, but you still have a very long lifetime for your building. So how will people realize, even if it is only 50 years from now, all of the things you built in for reuse within your building?
Well, you can't do very much if you build them bad from the beginning. You are stuck. Yeah, because the building is a signal that you give for 50 years. It's very difficult to alter a bad building from the beginning. The only thing you can do is to let ivy grow on it. That is the kind of options that are left, is to make it look slightly different as you let ivy grow on it. But otherwise it is difficult to temper except for to changing windows and so on and so forth. And appliances you can change it, but the frame in itself you can't do very much. Probably insulate it, hopefully. But then the shape of the building would change substantially. And that is the problem you have in a country like Italy, which has lots of historical values to building. So you can't insulate them afterwards. because then the facade won't look the way it has looked. It will start looking modern, which you don't want. And it will start looking like Manhattan and not like Milan or whatever it is, or Venedig. So you have those type of problems. So once you make a building and you make it wrong, you are stuck. It's very, very difficult and very expensive to alter it afterwards. Very, very expensive. And it is a hassle for the tenants, and that is why many times what they do is that they build a building for 50 years and bring it down after 20 years. You'll see most of the buildings which are coming down here in the city are 20, 25 years old, not really 50 years old, because the space has become so much more valuable. That is the case in China. I mean, you walk in China and they take a building out 3 years later, because the value of the space has gone so much that it is worth to build a higher building and bring it down. They do it. I mean, hardly 4 or 5 years old buildings and so on and so forth are brought down, because the land has become so valuable. And as far as the land is concerned, I don't know, there are some Canadians here. Is there anybody from Canada? Yes, you are. Have you been to Winnipeg?
Yeah.
Winnipeg is a city, I think if you get a chance sometime in life, go to Winnipeg. Winnipeg is just across Minnesota on the American side, and St. Paul, and you take a flight from there. So the interesting thing is that most of Winnipeg is underground. Most of the city is below the ground level. So you have shopping malls and you get underground and then you keep on walking, whole of the city. And the interesting thing is once you get underground 10, 20, 25, 30 meters, the temperature is stable. Whole of your air conditioning, cooling and all these loads disappear, because now you are not affected by whatever is happening outside. And Winnipeg is just about the coldest place on this earth that you can possibly come across. So they would have something like minus 30 outside, and then you walk around and it is perfectly comfortable with very little. And I was thinking that in this country, it works wonderfully fit. It's just sand. Dig it up 30 meters of band. Create a complete city under this city. So you don't have to expand. You can get this same amount of city once more without altering too much of your infrastructure. And that's what I believe China should also be doing. China should be digging in the ground instead of going up and up and up and up and up. But in China, they are actually doing it in Beijing. They have started making apartments now below ground level. They don't have any access to daylight, many of them, and the rents are ridiculously low. You can get an apartment very, very cheap if you are willing to live without access to daylight windows and so on and so forth. Some of them have this clerestory, a little window at the ground level, but rest of the apartment is under. So they do get some daylight, but the rents are incredibly low for those apartments. And many young people, I mean, who can't afford an apartment. Yeah, I mean, that is, you have to start somewhere, and they get an apartment there and they start there. So it is happening in China, but this is actually the place where they can have shopping malls and so on and so forth. And the reason why it can be done now and it couldn't be done before to a very large extent is that soon you will have organic light emitting diodes. The capability of organic light emitting diodes would be, you are using them in iPhones today, in case you want to know, that is OLED in iPhone, this thing, is that once you take them down, they will be as thin as paper. The whole lighting would be not like these huge things. They will be extremely thin. And the other is you will be able to make them in big sheets. So once you stick them up, they will give a feeling of a skylight. And the other is they can absolutely emulate the daylight spectrum outside. They would be tuned to follow the daylight, and they will keep on changing the spectrum exactly as it is changing outside. So you will have a change in intensity, which is of course a spectral change, and you will have a change in spectrum. I mean, they will be pinkish, little bit pinkish in the morning and little bit bluish in the evening as the daylight turns. And they would be yellow, whitish in the middle of the day. So they will change spectrum according to the seasons, they will change spectrum according to the day, and they will change intensity. It's less intense in the morning, more intense during daytime. Not, of course, the same level as daylight is, because daylight out, if you go, is, I don't know how many of you understand lighting, it's about 120,000 lux. And this is 500 lux, in case you want to compare. So you are sitting in 500, you walk outside, it is 120,000 lux. So it won't be 120,000 lux, but it will increase the intensity level, relatively speaking. And then it will go down, relatively speaking, but you will be within 500-600 lux. So in that sense, you could create these shopping malls, and you could create these areas where everybody would feel as if they are exposed to daylight and they are walking under daylight skylights. So now it becomes possible to create this kind of environments. Otherwise, you could say it's claustrophobic and people won't like it. They don't have access to daylight. It would not be very pleasant, and so on and so forth. So technically, we are moving in that direction. So space below ground, as commercial space, will become very valuable. So maybe you should go around and buy some property whereby you say, I want to buy the land under your house 40 meters now. And wait for another 15, 20 years. You people are so young, so 20 years go quickly. So it will become valuable. Okay.